Hi everyone, thanks for joining me and welcome to my talk, The Pitfalls of Privilege, Managing Excess Permissions in the Cloud. My name is McKay, I'm from Sydney, Australia, and I'm the Cloud Lead at Kablamo, which is a team of highly trained engineers specializing in cloud-native application development. I'm also a member of the Amazon Partner Network Ambassadors, which is a group of technical experts for the Amazon platform. This talk is on the concept of identity and privilege in the context of accessing cloud resources. However, I want to start off with something a little different, D-Day. In 1944, the Allied forces invaded the German-occupied Western Europe. Though thousands of military personnel were involved, very little of the entire operation. Of those who did know the full plan and the day of invasion, D-Day, they were not placed in a situation where they could be captured. Most of them only knew what they needed to know to do their part, even senior officers that were involved. And this resulted in one of the most successful invasion campaigns of World War II. They used the term need to know to describe the restriction of this knowledge and how it could be imparted. And the same principles can be used for the restriction of privilege in computer security. We call this the principle of least privilege. Least privilege is a strategy used by security practitioners to ensure that users and systems only have access to the resources they need to perform their job or function and no more. In a cloud environment, it's generally associated with the identity and access permission model, also known as IAM, that is used to grant access to these entities, network and cloud account segmentation, or the broader cloud security posture within an organization. Segmenting users and systems from each other limits their capability for threats and actors to use compromised credentials or system components to then gain an access to other, potentially more critical systems. This is the same effect we saw in R&D. By using least privilege, we are restricting the blast radius of any potential compromise, which may reduce or negate any attack's potential impact. But there are challenges to least privileges. Least privilege requires knowledge of the high complexity of IAM policy syntax and requires a deep understanding of the components within a specific environment. It's easier to over-allocate permissions and forget to remediate them than it is to start from the ground up. Policies do change as environments change, and security administrators need to be aware of the implications of this. There will, however, always be the need for administrators, and these administrators need access to fix production issues in a timely manner. It should be a very restrictive list of people, just like the list of officials who knew of D-Day and the invasion plans. And they do require access to everything. Because we cannot predict in advance what will go wrong with a specific environment, otherwise we would have catered for it during the design, they do need access to everything in order to remediate the actions in a short amount of time before it starts to impact the business. Now, this may not be via a root account or a system administrator account or a master account, depending upon the cloud provider, but the need is there. And we usually encompass these access mechanisms in what we call a break glass, which is something along the lines of opening a safe to get a two-factor hardware code, or sending a notification to the entire team, informing them that the action has been taken so everyone is aware that this account is being accessed and that those actions should be in line with the procedures that are in place. So let's talk about how this works in a cloud environment. I'm going to use AWS in this example. And AWS has this problem of moving goalposts. There's an ever-expanding boundary of what levels of privilege and access we need to think about. It started off with traditional instances, or VMs, and security groups. Then it moves up to host and placement groups, and then to subnets and network ACLs. And this is where a traditional data center or traditional server room would stop. But AWS takes it many steps further. So we have the concept of virtual private clouds and resource groups, which are collections of resources. We can then extend further into transit gateways and regions, having multiple geographic regions where our compute resources live. And then where it used to stop is the AWS account itself. An account compromise would compromise all of your cloud resources. We can take it one step further recently with the introduction of organizational units and organizations itself, which are collections of accounts. So an organizational administrator is responsible for multiple accounts, And today, AWS recommends the use of organizational units as a way to restrict privilege into specific workload functions. So that could be dev, test, and prod, or one project versus the other. So there's a bunch of things we need to consider when we're architecting within certain cloud providers, and this will change based on the cloud provider. In the AWS cloud, IAM is used to define a syntax of privilege that is used to access resources within the cloud. An IAM policy consists of actions, the thing that is being performed, principals, the entity that is performing the action, resources, the entity that the action is being performed on, and optionally a set of conditions that need to be met before the action is taken. Now, principals are typically a user, a human, a person that is performing that action. In AWS, this is typically an IAM user, but this could also be a federated user. So that's Google Login or Active Directory or Okta, or a number of different third-party identity services. But humans aren't the only thing that require privilege. Systems typically require privilege to talk to each other in an authorized way. Or accounts require privilege to talk and exchange data between different workloads, different accounts. Cloud services also need to be authorized to do the actions that they need to do. Or everyone, a special privilege that is used to define what resources everyone can have access to. And this is typically public services, like a website, like a cloud service that everyone should have access to, the service you're providing. So let's talk about a common failure case, AWS S3, also known as the simple storage service. But in many cases, it's anything but simple. Exposed AWS S3 buckets are one of the most common misconfigurations in the AWS cloud. And this is typically caused by a confusion on multiple layers of security available through the service. Though AWS S3 is a secure by default service, that is, if you create an S3 bucket, it is not publicly exposed by default, we often need to access these resources from internal systems. And granting this access can often go wrong for those who aren't specifically trained in its use. So let's go through another example of how things can go wrong or what bad looks like. Here we have a policy designed to allow whoever is running the action to perform EC2 run instances. That is, create an EC2 compute instance, essentially a VM, and start that compute instance. We also give it IAM pass role, which means we want to give a specific identity to the instance so it can, for example, access S3 or do other actions in the cloud. Now, where this goes wrong is that these actions are contextually not attached to each other. So the IAM pass role action is individually a problem, especially when it's assigned to the cloud resource. This means that the user who has this policy attached can then obtain the permissions of another role in any aspect. So that could be the administrator role, for example, which means game over. So when we move over to the next slide, we see what we can do to improve this. And to fix the issue, we split the policy in two. We're still allowing EC2 run instances in any form because there is no context of resources there because you're creating that instance. But when we do the IAM pass role, we're making sure that we use a specific role that is allocated to this instance. And not only that, we also ensure that when we do pass the role, it's passed to the EC2 service. It's not passed to a user or an account. It's specifically for the purpose of running that VM. So let's talk about how tooling can help developers and administrators make the right choices when writing their IAM policies. There are typically two approaches when it comes to tooling for identity, static and dynamic. In the static approach, we analyze the infrastructure as code, application code, or even architectural design to determine the minimum permissions required to deploy before it's deployed. Conversely, in the dynamic approach, we analyze the deployed environment, usually with auditing tools like CloudTrail, to determine the actual actions that are required through observation over time. One approach is not inherently better than the other, and often we use both sets of tooling in our approaches to achieve the best result. So let's take a look at some examples of these static tools. Firstly, we have the PureSec CLI, and PureSec CLI has a focus on serverless applications and the way privilege is enforced. Second is Parliament, and Parliament is from Duo Labs, and that analyzes the consequences of IAM policies. So that's things like how do wildcards affect the actual actions that are being committed? And then there is a tool that I created called AWS Least Privilege. And this analyzes the templates of CloudFormation, which is an infrastructure as code tool, to generate a service role policy. Now let's take a look at some of the examples of dynamic tools. One of the first tools that came about in this area was RepoKit by Netflix, which uses CloudTrail to figure out in a given policy what actions are actually being used and what are not. And this approach was copied by AWS themselves when they made Access Advisor and Access Analyzer. We also have Policy Sentry from Salesforce, Cloudsplaining from Salesforce, which is an amazing name, by the way, and Cloud Tracker from Duo Labs. And there's a bunch of security tools that will also give you an idea of over-excessive privilege in a specific area. These include Scout, Prowler, SecurityMonkey, and TFSec. So I mentioned before that I made my own tooling for achieving least privilege, and I wanted to go through the challenges that I faced during the development of this tooling. So things like non-documented actions or non-documented conditions, which means I don't know what's going on. I'm basically working blind, and I have to look at audit trails to figure out what's going on. There can sometimes be inaccurate documentation, which leads you down the wrong path. There can be global conditions, which are really relevant to the way you access a service rather than the fact that you have access to a service, which is very important, but sometimes really hard to achieve as it's very environment specific. Legacy features that I sometimes can't access, like SimpleDB or EC2 in the AWS world. There could be null conditions, which is the lack of presence of a condition or property on the resource. And we can't enumerate everything that's not there, it just doesn't make sense. And then things like tags are also very specific to a customer environment, which may be relevant to you, but is really hard to automate. So what are my tips for achieving least privilege? Well, the number one thing is to train your developers. Train them to understand the risks of what's going on and to understand the syntax of IAM. It's very important. It's the number one thing we need to do. Invest in training for your employees. You also need to review the permission schemes when architecting or re-architecting applications. Periodically go through these, see what's missing, see if there's anything that's over-provisioned, and adapt accordingly. Use the static and dynamic tooling to review infrastructure, like I previously mentioned. There's lots of tooling out there. All the tools I mentioned in this slide pack are open source, so you shouldn't need to pay a cent. If you're using the AWS cloud, use permission boundaries to deny dangerous actions. So that's anything to do with IAM or anything that could escalate your own privilege. And finally, automate everything. Everything here should be in a CI/CD pipeline. We should be deploying privilege using Git flow, and in code reviews, we are making sure everyone understands the implications before they take an action. So that's my talk. Thanks for listening in, and if you have any questions, please send them through the chat now. Otherwise, thanks for listening.